Hello and welcome. My name is Jerry Hall. I'm a student over at OSU IT over here in Oklahoma. I actually live here too, even though it's an online course. And I'm doing a presentation today over DHCP, which stands for Dynamic Host Configuration Protocol. So let's get started. What does it do? DHCP is a protocol used to hand out IP address configurations to devices on the network automatically. So what this means is you set it up, you plug a computer or a phone or whatever you need connected to the network into the network, and this service gives it everything it needs to know in order to communicate with other devices on that network. So it's a great tool, especially for medium to large size networks, because you don't have to go set all that up yourself every time. You tell one service, here is a group of addresses you can use for any device on this network. So have at it, good luck, have fun. That being said, it's not meant for everything. Some things that you may not want to use DHCP on would be any kind of long-term network resource that you may be trying to utilize in your environment, such as a printer or a server or a VLAN IP address on a switch, things like that. You definitely want to statically address, because that way it'll always be that and it'll never change. We'll go over that a little bit more here in a second. So how does it work? Dora the Explorer, famous cartoon back in my day. That's a cool acronym for it I found on the internet, DORA. So the first step that happens is the client screams out, hey, discover, server, something out there with an address for me. Can I have one, please? Hello, is anybody out there? Up next we have O, offer, which is the whatever device the service is running off, saying like, yeah, I can hear you. I've got an address for you right here. Do you want it? And then request comes back from the client saying, yeah, I want that. Let me get that address. I would like to formally request that address. So following that, the server or whatever is hosting the service follows up with an acknowledgement saying, okay, well, this is your address, and I'm going to go ahead and notate that so I can keep track of things in my handy dandy little DHCP notebook. So this is more or less the conversation that goes down between a client and a DHCP service whenever it's initiated. It's way quicker than what I just said, but it'll kind of slow it down so you can understand it. How does it know? So how does it know what addresses to give for what? So the way this happens is it uses a scope of addresses that you've assigned to it when the service is configured in the first place, and it'll contain, information like the IP address, network that it's on, the subnet that's assigned to it, and the range within that subnet that it is allowed to use to give out to devices. This next little tab here on my slide is a PIPA, automatic private IP addressing. So what this does is if your client looks for a DHCP server and here's crickets, it's going to say, you know what, we'll give you a 169 address, which is 169.x.x.x, and that'll just be a placeholder for you. And so if you see a 169 address, you know that there is something wrong because you are not getting a DHCP address. Exclusions to your scopes that you configure in DHCP are important. Let's say you created a scope on DHCP and 2 months later you bought a large office printer that you want to have a static address within the scope that you've already configured. Well, instead of ruining everybody's day on the network and having to reconfigure that whole service, you just exclude an address out of that service. DHCP will no longer hand that particular address out, and you can keep your brand new office printer on an address for as long as it shall live, so you never have to mess with it again once you've set it up the first time, because nobody likes messing with printers. So exclusions are important because printers are terrible. When does it know? So when does it know what? When does it know when to give a new address? Well, whenever you plug in a new device. When does it know to get rid of an address? whenever the lease expires. So DHCP also comes with a lease, which most time is configurable to set up to whatever length of time you choose. But basically what happens is this lease is given out when the address is shot to the device on the network. And if it is inactive when this lease expires, and has been, it'll take that address back, put it back in its bank, and say, you know what, I'm going to save that for the next guy. So this is important, especially when you consider there's a lot of public networks like that may come out of some kind of restaurant, library, wherever free Wi-Fi is provided. Your scope's going to run out quick if you've got 200 people coming in there every day using your Wi-Fi, because that's 200 different devices, and they're going to go away, and then another 200 will come back in the next day. It may not be the same people. So that's the way the service says, you know what, we're going to stop right here. I'm going to go ahead and take back those addresses that we haven't used in a while so that other people can continue to use this service. So where does it go? So where does the DHCP service sit? Well, it can sit and be configured on a router on the network. This would, you tell it what scope it gets, and then when a new device hits the network, it'll shoot it out. You can also set this service on a server. It'll do the same job. You can bundle it on a server with some other things, to handle multiple roles like Active Directory or group policy management, anything like that. Wherever you put it, just put it one place. Don't put it more than one place, because man, that's going to ruin your day. When you've got two DHCP services running on the same network, it will try to hand out IP addresses to multiple devices. Well, multiple IP addresses to multiple devices. It's a terrible thing to happen. I've had this happen once before on a production environment I was working on. We had an integrator came through, dropped a new DHCP service on the network, thought that they had shut the old one off and that everything was going to be hunky-dory. Well, it shot new addresses to every device, and then everything that was pointed with the original addresses was destroyed, and some people got in trouble. Some people had to find new places to work, and some people with lots and lots of money were very, very angry. So I would not recommend doing that. Why do I care? Well, it makes everything easier. Literally everything. If you're an IT professional in the workforce and you're out there configuring networks, this turns a network with 100 devices into, well, let's plan out which device gets which network. Let's record that on a table somewhere, and let's, deploy this one device at a time and hope we don't make a mistake. There's a lot of human error that can happen there, and that's such a tedious process. And if you're not an IT professional, well, same reason. You don't want to have to set that stuff up. You just want to connect to your router at home or in the business or office or wherever you're at, and you want to be able to go use the tools that are available on the internet, social media, video, entertainment, news, some really important stuff. You don't want to have to worry about, okay, well, what gets what? Do I really need to type in an address for every single thing in my house? My washing machine that is now Wi-Fi enabled, I have to statically assign an address? That would be a miserable life. So it makes life easy, which is great. So this thanks for all the fish slide here. Just kind of wrapping up and summarizing. What does it do? Well, it hands out IP addresses, which is great because we don't want to have to do that ourselves. How does it work? Well, it sends out the DORA acronym. Says, hey, is anybody out there? Server says, yeah. Here's an address. Do you want it? Client says, yeah, that'd be great. Let me take that address. Server says, all right, here you go. I'm going to write that down so I don't give it to somebody else. And then you all fight over it. So how does it know what addresses to hand out? You've told it. You set that up when you set up the service. And it keeps track of all that in a table with its leases to know which addresses are available and which addresses aren't. When does it assign addresses and when does it terminate addresses? When a new device is on the network or when leases expire and it can no longer communicate with the device that holds that lease. So, where does it go? It goes wherever you want to put it that makes the most sense for your environment. You can put it on a router, you can put it on a server. It just kind of depends what makes sense. If you've got layers of security, or that may be wrapped around a router, or that may be wrapped around a server, or you've got a server that you don't have doing many jobs, and your router, man, you've got a lot of routes in there. You don't want it to have to think about all that other stuff too. It just kind of depends where you want to go with it. Why do I care? Well, we all know why we care. Because easy stuff is nice. Hard stuff sucks. So, that being said, I hope you all have enjoyed my wonderful presentation here of DHCP. And I hope you have a good morning, evening, afternoon, or night, whatever time it is, wherever you're at in the world. Thanks.